right, so in these notes, we're going to be finishing up the R2 notes. So earlier we looked at this flow chart here. So we always check for a GCF first if there is one. And then how we factor depends on whether there are 2 terms, 3 terms, or 4 terms. The first examples we're going to see in this video are where we have 4 terms. So anytime there's 4 terms, we're automatically going to use grouping. And then grouping is very important because we also have to use it when there's 3 terms if the leading coefficient is not 1. So all the examples we're going to see today, we are going to be using grouping. So let's find our examples. Okay, so we're on, if you have the printed note sheet, we're on examples I and J. If you don't have the printed note sheet, then you should write these examples down in your notebook or whatever you're taking notes on. So our first example of the day is example I right here. X cubed minus 2x squared minus 3x plus 6. X cubed minus 2x squared minus 3x plus 6. So if we look at all of the terms, there's not a greatest common factor of all 4 terms. And I do notice there are 4 terms, which means the way I'm going to factor this is I have to factor by grouping. So the reason we want to group is because if I group these into smaller groups, each group could have a GCF. So there's not a GCF of all of them, but I'm going to group them into groups of 2. So I'm going to group the first 2 together. I'm putting parentheses around those. I'm also going to group the second 2 together. One thing to notice is this minus right here, I'm going to include it in the parentheses with the 3x. And to make it look like these are not multiplied, there is still a plus sign in between. So I'm going to go ahead and rewrite this with the 2 groups. I have x cubed minus 2x squared as my first group, so it's in parentheses, and then plus negative 3x plus 6 as my second group. Okay, so now the next thing I need to do is find a GCF, or greatest common factor, of each group. So this group, x cubed minus 2x squared, does have a GCF. That GCF is x squared. That's what they have in common. So I'm going to factor out the x squared. Remember, factor out means divide out. And when I divide out a GCF, I put it in the front. So I'm going to have an x squared, and then inside the parentheses will be what I have after I divide. So right here, x cubed divided by x squared is x. And then right here, negative 2x squared divided by x squared is minus 2. All right, so that's what the first group looks like. I took out a GCF of x squared. So I have x squared times x minus 2. Okay, then I've got the plus sign in between. Now this is my second group, negative 3x plus 6. The GCF of that, there's only a number in common. The common factor is 3. However, I want to factor out a negative 3 because when we factor out a GCF, I usually want my first term to end up being positive. All right, so I'm going to divide or factor out a negative 3, which means I'm dividing both of those by negative 3, and I put the negative 3 in the front. And then in the parentheses, when I divide, now a negative 3 divided by a negative 3 would give me a positive 1x. So I'd just be left with x. Right here, I would be left with minus 2. So that was very important to take out a negative 3, because in order to continue, I need to have another common factor. And so each group should have something in common, and hopefully you can see that they each have an x minus 2 in common. So now our GCF of each group is x minus 2. And so I'm going to factor out the x minus 2. Factor out means divide out. I'm dividing both groups by x minus 2. Also, don't forget, when you take out the x minus 2, it goes in the front. So I have the x minus 2, that GCF in the front. And then the other factor is what's left after I divide. Right here, if I divide out x minus 2 divided by x minus 2 from the first group, I'm just left with x squared. And then from the second group, same thing. If I divide out the x minus 2 and the x minus 2, those divide out, and I'm just left with minus 3. Now those are my factors, x minus 2 and x squared minus 3. So if we're factoring by grouping, first we group into groups of 2. We do a GCF of each group separately, and then we do another GCF. The two groups should have a common factor. And then sometimes, occasionally, the terms we found could factor more. Like in this case, if we have x squared, but x squared minus 3 does not factor anymore. All right, so those are my factors, x minus 2 and x squared minus 3. All right, let's do another example. So if we look at example J here, so write down example J in your notes. If you're writing down in your own notebook, J is x to the 4th minus 4x cubed plus x squared minus 4x. This time, if I look at all my terms, we actually do have a greatest common factor of all 4 terms. So if I'm looking at my flowchart, I would take out a GCF first. So I can factor out an x out of all of these. If we factor out a GCF, it's going to go in the front. And then when I divide by x, this would give me x to the 4th divided by x would be x cubed. This term, 4x cubed divided by x, is 4x squared. This term, x squared divided by x, is just plus x. And then this term, negative 4x divided by x, is minus 4. Okay, so now inside the parentheses, this can factor more, and this has 4 terms. So once again, since it has 4 terms, I'm going to factor by grouping. All right, so the next part when I'm factoring by grouping, I'm going to just focus on what is in the parentheses. And at the end, I want to make sure I include this x that I factored out. Okay, but for right now, I'm just going to factor what's in the parentheses. So because there's 4 terms, I'm going to try to factor by grouping. I'm going to group the first 2 together and the second 2 together, and then look for a GCF of each group. So my first group is x cubed minus 4x squared. The GCF of those is x squared. So I'm factoring out an x squared, or that means dividing by x squared. Don't forget to put the x squared in the front. The GCF always goes in the front. And then what's left when I divide is x minus 4. Okay, so I divided both of these by x squared. All right, then I got a plus sign here. Now this second group is just x minus 4. Technically, there is not a common factor. You don't really have to take out a GCF, but you could just say the GCF is 1. The only reason we'd want to factor out a 1 or divide by that 1 is so that when I write it, I have a 1 in the front, and then I have x minus 4 left on the inside. That just makes our format look a little more familiar. All right, so I grouped, and I took a GCF out of each group. Now, we hopefully notice that they have another common factor. Both groups have the same factor. If these were not the same, we could not continue. But my GCF now is x minus 4. So I'm going to factor out the x minus 4, which means divide it out. Again, when you factor out a GCF, the x minus 4 is still there as part of our answer. Then the other factor is what's left on the inside of the parentheses when we divide. So from this group, if I factor out the x minus 4, I'm just left with x squared. And then from this group, if I factor out the x minus 4, I'm left with a plus 1. That's why it was better in this case to write the 1 on the outside so we can see what our 2 remaining factors would be. All right, so there's our factors. Oh, wait, kidding, not done. As I said at the beginning, we factored out an x. So this part, these 2 factors are just the part that was inside. I almost forgot that we had this x. It's still a greatest common factor, so we still want to include it. Okay, now that's our entire factored expression. So we have x times x minus 4 times x squared plus 1. And if we were to distribute and multiply that out, we'd end up with the same expression we started with. All right, so even though those polynomials are bigger because they have 4 terms, we needed to do grouping first because we're going to use grouping on these next examples here. So these are our last 2 examples in section R2. So write down example K. We have 5x squared plus 12x plus 7. Okay, so write down that problem. So on this one, notice there's not a common factor of all of them. So I'm going to go to the flowchart for just a second so we can look at what we're doing on this problem. So first, we look for a GCF. There isn't one, so I'm going to continue. This has 3 terms, and it is in the form ax squared plus bx plus c. So then I have to look at the leading coefficient, whether a is 1 or a is not equal to 1. A in this case was 5. It was not equal to 1. So this is a case where I'm going to have to rewrite the middle term and then use grouping. So that's why we had to know how to use grouping, because we're going to have to use it on problems like this. All right, so let's go back to our example. Okay, so when I have a leading coefficient that's not 1, I know I'm going to need to rewrite the middle term. Okay, so first of all, this is in the form ax squared plus bx plus c. That's good to recognize what number is a, b, and c. But what we're going to need to do is we're going to need to rewrite the middle term. We're going to be rewriting 12x as 2 separate numbers. So I'm looking for numbers that add up to 12x. However, they're going to multiply not just to c, but they're actually going to multiply to a times c. So in this case, they're going to multiply to 5 times 7, or they're going to multiply to 35. Okay, so I'm looking for the 2 numbers that multiply to be 35, but add up to 12. In this case, it's fairly easy to figure out. The 2 numbers are going to be 5 and 7. So what that means is I'm going to rewrite the middle term, 12x, as 5x plus 7x. Okay. It doesn't matter which order you write them in, because if I wrote 5x plus 7x or 7x plus 5x, it still is the same as 12x. All right, so I'm going to rewrite my polynomial. The first term doesn't change. It's still 5x squared. The 12x, I'm rewriting it as 5x plus 7x. And then the last term, the plus 7, from here also doesn't change. So all I did was rewrite the middle term. Now, hopefully you notice that we have 4 terms. And since there are 4 terms, we need to factor by grouping. So that's why knowing how to factor by grouping is important for this. All right, so I'm going to group the first 2 together and group the second 2 together and look for a GCF of each group. So the GCF of the first group is they have a 5 and an x in common. So I'm going to divide out a 5x. So I have the 5x in the front, and then in the parentheses, 5x squared divided by 5x. That would just divide to give us x. Now right here, be careful, we're doing 5x divided by 5x. Something divided by itself is actually a 1. So even though they divide out, it's not a 0. 5x divided by 5x is 1. So for the first group, I have 5x times x plus 1. All right, the second group is 7x plus 7. So my GCF there is 7. So if I factor out a 7, I have the 7 in the front. And then in the parentheses, I would be left with like x right here. 7x divided by 7 is x. And plus 1. 7 divided by 7 is 1. So after I took a GCF out of the second group, I have 7 times x plus 1. Now, once again, we should notice we have a GCF for each group. Both groups have a common factor of x plus 1. So again, I'm factoring out the x plus 1, divide by x plus 1. The x plus 1 is one of our factors that goes in the front, so I have x plus 1 in the front. My other factor is what's left when I divide. From the first group, if I divide out an x plus 1, I'm left with 5x. And for the second group, if I divide out an x plus 1, I'm left with plus 7. So these are my two factors, x plus 1 times 5x plus 7. Okay. Now notice if we were to multiply this out, we would get the same factors that we started with, 5x squared plus 12x plus 7. Okay, one thing I do want to point out is that in your Algebra 2 class, you may have used the X method. And while you can use that to help organize your work, just using the X method by itself doesn't work. You're still going to have to rewrite the middle term and then do grouping to get the right answers. So if you have seen this before, maybe this will look familiar. We're looking for numbers that multiply to be 35 and add up to the middle term in this case, which was 12x. So those numbers are the same numbers we found earlier, 5 and 7. The reason I don't like to use this is because a lot of people, if they use the X method, then they just want to write their two answers as x plus 5 and x plus 7. But as you can see, that is not correct. That does not give us the same answer we start with. So if you do choose to use the X method like this, you do have to remember it can help you find your two numbers, but you still have to do this step where you rewrite that middle term and you still have to use grouping. Okay, so I just wanted to point that out in case that is something you've seen before and find useful. Okay, so let's do our last example. So example L, write down example L. The polynomial we're trying to factor is negative 6x squared plus 11x plus 7. Negative 6x squared plus 11x plus 7. There are two ways we can start this problem. If we're using the factor tree, the first thing is a GCF. Although the numbers don't technically have a GCF, some people, if they see a negative leading coefficient, they prefer to factor out a -1 and then factor from there. That way they don't have to deal with a negative leading coefficient. You can also just use the numbers as is and use this as your A, and this is your B, and this is your C. Okay, so I'm going to just leave it as is and use A, B, and C. So I am going to need to rewrite the middle term. We always want to rewrite the middle term. So I'm going to rewrite 11x. So we're looking for numbers that add up to 11x. However, they need to multiply to be A times C. So they multiply to be -6 times -7 or -42. So I'm looking for two numbers that multiply to be -42 and add up to 11. All right, so to find those two numbers, it's maybe not as obvious, so I'm going to make a list of factors like 1 and 42, 2 and 21, 3 and 14, and then 6 and 7. Now, because it's adding up to a -42, I'm looking for two numbers that multiply to be a negative. So one of them has to be a negative. And I'm trying to get two numbers that add up to 11. So the two numbers that are going to work are 3 and 14. So to add up to an 11x, I need a +3 and a -14. So I'm going to rewrite 11x as +3x and -14. All right, so let's rewrite that middle term. So negative 6x squared is still my leading term. I'm rewriting 11x as a positive 3x and a negative 14x. And then I still have the plus 7 as my last term. Okay, so now rather than having 3 terms, now I have 4 terms. And anytime we have 4 terms, we can factor by grouping. So after I rewrite the middle term, I can use grouping. So I'm going to group the first 2 together and the second 2 together. Notice I kept the negative, this minus with the 14. All right, so my first group has a GCF. Let's see, I have a negative 6x squared plus 3x. The GCF, the number they have in common is a 3 and an x in common. However, because my first term here is a negative 6x squared, usually we want it to be positive, so I'm going to factor out a negative 3x. Don't forget to put the negative 3x in the front. And then when I divide that out, this would divide to give us a positive 2x. And then here, 3x divided by negative 3x is a negative 1. Okay, so don't forget that that divides to give us a 1. All right, the second group, negative 14x plus 7, those have a GCF of 7. But once again, I usually want my first term to be positive. So I'm actually going to factor out a negative 7. So factor out a negative 7, put it in the front. Don't forget to put the GCF in the front. And then I have a, this would be divide to give us a positive 2x. Negative 14x divided by negative 7 is positive 2x. And then positive 7 divided by negative 7 is minus 1. Okay, so now from here, we can see another common factor. Each group now has a 2x minus 1 in common. So I'm going to factor out the 2x minus 1. So the 2x minus 1 is my GCF, so I wrote it in the front. If I divide out the 2x minus 1 from the first group, the 2x minus 1s divide out, and I am left with a negative 3x on the inside of the parentheses. And from the second group, if I divide out the 2x plus 1s, I'm left with a minus 7 on the inside of the parentheses. Okay, and this would be my 2 factors. 2x minus 1 times 3x minus 7 times negative 3x minus 7. Okay. So as I mentioned at the beginning of this problem, some people could have preferred to factor out a negative 1 first and then factor what was left. If we did that, notice these terms are both negative, negative 3x minus 7. Here's what that would look like. I could take a negative 1 out of this factor. So I'd have a negative 1 in front. And you don't really have to write the 1. But then this factor would become 3x plus 7. Okay. And then the 2x minus 1 would stay the same. So if we would have factored out the negative in the beginning, then we would have had these factors instead. Okay, so we still end up with the same or with equivalent answers. They just might have a little bit different form. Okay, so now we have finished up all of the types of factoring and all the notes for R2.